All right, thanks everyone for joining us. I'm Damon Woods, standing in for Elizabeth. She's off in Sweden today, or en route to there. Welcome to the Integrated Design Lab Building Simulation Users Group. If you haven't joined us for lectures before, we put these on every month or so. Our next one is going to be in February. We'll have two presenters, one from PNNL and one from Florida as part of the sensor suitcase, which is just a little kit of sensors that allows you to easily calibrate a building. So excited to see that. Just a couple of housekeeping issues. Those that are attending online, you'll be muted during the broadcast, but type your questions into the chat window, and we'll address those kind of during the Q&A portion of the presentation. For those in the room, please fill out the evaluations. I think you all filled out the raffle tickets, so put your name and contact info on there, drop it into the little Idaho Vandals cup here, and we're going to be drawing for prizes in the next week or so. So pay attention to your email. I know Elizabeth has some really cool prizes, several $100s worth of prizes going out to people. Smart plug strips, Wi-Fi plugs, you know, fun LED lights that are remote controlled. So all sorts of fun stuff. So one of the benefits of attending in person to our BSUG session. For today's presentation, it's going to be on LightStanza. We have Dr. Daniel Glazer here. He is the founder and principal of LightStanza and leads its research and development efforts. He's a frequent speaker at major industry venues, including Greenbuild, Light Fair, and the DOE Radiance Workshop. He's received research grants from DOE and the National Science Foundation, and has a string of academic accomplishments, including a bachelor's from Columbia University in computer science, a master's in the same subject from Cornell, as well as a master's in architecture and an interdisciplinary PhD from UC Berkeley. In addition to Dr. Glazer, who we have here in the room, we also have a remote presenter in Boulder, and that will be Sydney Nelson. And she plays an integral role in bridging the gap between design and engineering by leading product iterations and implementing design using HTML, CSS, and AngularJS. She's also involved in the integration of digital marketing materials. Sydney received her Bachelor's of Arts in Interdisciplinary Media Arts Practices, along with a minor in Technology, Arts, and Media from UC Boulder. So thank you both for your time today. I'll let you go ahead and take your presentation away. And if you wouldn't mind turning on your little mic, should be good to go.
Damon, am I being broadcast now? So welcome. People that have signed in either online or here will get a free month of our software. So yeah, so our software we think is really neat. So it's called LightStanza, and I'm the founder, and I really felt that daylight needs its own tool. It's a hard subject, but we're trying to make it easier. Daylight, as we know, touches on many aspects of people and buildings. And in this case, we just sort of highlighted a few of them. If you have good daylighting, it should promote good health. If you have good daylighting, you should have some good visual comfort, etc. So with the past couple decades, there's been a lot more interest in daylighting as a building system. Traditionally, energy for heating and cooling has been studied for efficiency, and there's been some studies about productivity by adding windows and skylights. People will be more productive, and also there are correlation studies showing that if you add daylight in the spaces, people will shop more and buy more things, and so people generally like it, and there's been research with this in the past couple decades. Another reason that people employ daylight in their designs is that it makes us sleep better. So if you have daylight in your buildings, we're trying to manage our hormones, and the light will actually tell us to stay awake, and when you don't have light, our bodies get tired and want to go to sleep. So one of the main benefits of having a well daylit system is just to help circadian health and tracking so that people know when to go to sleep. Likewise, our receptors are sensitive to different colors of light, and so during the day we seek out blue light, and later at night the orange-reddish light is more comfortable, and that's what we want to strive for with our lighting systems. Likewise, there's big potential energy savings by using daylight properly. You know, these days with LEDs that may be getting less, the savings, but also electrical systems are also getting more costly to use. So a building like this, which doesn't seem too happy to work in, is also not going to be energy efficient. If you employ it right, you can still get views. This is a case in Europe where people are able to work here most of the year without any glare because the windows here are facing north. And so they will get glare selective times in the year, early in the morning in the summer, later in the day in the summer. But otherwise, you can plan for it and also achieve a lot of benefits of the views. Okay, so speaking of planning for it, so this is a library. I found it on the slide on the left is what I found somewhere written up about the success of the lighting system, and they're using glass here. And then on the right was, I found the photo on a public archive, like on Flickr. So it turned out this sort of open daylit space turned out not to work very well because people don't like just being blasted the whole day. So in this case, if there was more planning involved with the daylight system, this was overlit, they would have taken better precautions in putting beach umbrellas at the space. And so if there was more precautions, there could be a more insulating material, so we wouldn't have so much glass, and et cetera, et cetera. So it's important to actually go beyond just saying we're going to add, windows and skylights to buildings, that they let them to actually try to get it right with like your other building systems. Likewise, here's a building photographed in California, and they look like they were trying to plan out some solar design here, but as we can see, it's not quite right. If it was right, we probably wouldn't see all the blinds closed. And so there's a good attempt at this, but a little more analysis could have helped them sort of size the right overhang. Okay, and so likewise, what I was saying before, this is actually the Empire State Building. This is a photo sent by a colleague in Colorado. And you can see that there are a lot of windows, but it's not working because the electrical lights are on and the shades are half down because of the glare. Okay, so why LightStanza? So, the founder, I wanted something that was the easiest way to good quality information. And so this is a building in Fort Collins that was used LightStanza. And in this case, we're able to look at light levels that were actually produced by radiance. How many people here know about radiance? Or, okay, fair amount of people. So we're using radiance for accuracy. Radiance has certain capabilities that are just in radiance. I talked with someone at the Department of Energy a couple months ago, and he says, well, look, there's a lot of people claim that they do lighting engines that can do what radiance does, but the reality is if they could do it, we wouldn't keep working on radiance. And so they're doing certain things like they could handle complex definitions of materials, BSDFs, and certain things that aren't available on other software yet. So the value that we're providing is we want to be as accurate as possible, and so the only other things that I think are comparable to what we do are PC. How many people use PC tools with Radiance by chance, or just use Radiance directly? Okay, so it's hard to do. The downside of that is they're hard to do. People are much more interested in using the web these days to do everything in life, and so that's what we're offering. There are others, web tools out there, but their priorities aren't necessarily accuracy, and so that's what our company does. And so we also, because we're focused on daylighting, and I'm the founder, we do have a high value on R&D in our product. And so in this case, this was actually presented at the Radiance workshop with a colleague. That's where I met Dylan. And we were looking at how do you actually figure out where the sun is in the sky and how often it gets in your space. It sounds like an obvious question. It's an ancient question, but actually computed efficiently and accurately, it's not obvious. And so this is part of our talk. Up here, we're just looking at things about identifying glare in buildings. And so traditionally with illumination engineering, we're measuring light at the desk, because in 1900 we're all really worried about our pencils on the desk and making sure we have enough illuminations to get that. So nowadays, that's a rare case. It's much more vertically oriented, our lighting quality. And so we offer the ability to look at things like daylight glare probability. And so you can make renderings with the software and actually find out when daylight's going to. And so you could actually figure out, what if your blinds are going to be open or closed. They're really going to get the benefits of these windows and skylights. Yeah. So we also can be used at different stages of the design process. So we've heard from people they really like it in early because of design. That's where you make major decisions about. But as you move further in design, as people know, as the details get more detailed, it actually makes a difference. In this case, we're inside an atrium looking out. A lot of different choices that can be done, and with a tool like LightStanza, you can actually put in different types of glazing. You can put in redirect glazing, different films. You can look at just different geometric things. There's no real limitation because we're focused as a daylight in some geometry and materials. And so I think with energy modeling, there's some other aspects that are. So in this way, we're fairly flexible.
Sorry. Would you mind switching over to this mic and turning that line off?
Sure.
This should be a little bit better. Thank you. Okay, thank you. And then lastly, has anyone done lead documentation for a daylight credit here or online? Has anyone online done a daylight credit calculation? But what are the barriers for doing the daylight credit? Is it something that, has anyone wanted to do one and not done it? Or is it just you're doing other stuff and daylighting hasn't been your thing? Who's tried to, what would be a barrier to getting the daylight credit for a lead, the USGBC lead credit? Does anyone online or here want to say what a barrier could be? Anyone online or anyone? Getting the metrics. Okay. How many people have done a LEED compliant building or interested? Okay, so a couple hands. How about online? Are people doing on LEED buildings? So, so part of this is we're trying to streamline this process, and so people that are going for LEED buildings, the idea is that you can put it into a system like LightStanza, which is a daylight specific tool, and we'll show you some of the output, and it will just go through the compliance report completely for you, and it's not an easy task to do. Okay, so about our software, what can we do? So you drop your 3D model in the LightStanza. Right now we support SKP, SketchUp models, and also we just started IFC, which is an export from a tool like Revit or ArchiCAD. And so the idea is you can drop your 3D model in, and then you'll be giving a demonstration, and then you'll be able to make renderings. So the rendering will go on top of your 3D model. You can also do false color inside your browser. So this is just something that you can actually get a more numeric feel of your space. So one of the challenges with looking at light and studying light on a computer screen is you don't really know if that's what it looks like, because a computer screen actually has a limited range that it can actually display. I know computers are powerful, they're changing the world, but the reality is when you buy a TV or something, there's a certain brightness to it. And so the idea is that you want to be able to look at a false color to really understand those numbers, like you would look at a temperature map or of something else. And so we offer this that's real time inside your browser. And also you can run animations in your browser. And so the idea is you drop in your 3D model, you can get this information, and you can just use your browser. You don't have to install heavyweight PC software to do any of this. And right now we actually, you don't have to install anything to use LightStanza. Okay, so you can use it throughout the design process. I mentioned here's a firm, their Denver office was working on a school in Aspen, Colorado, and in this case they were just looking at LightStanza and how you could use a trellis for it, and it looks pretty good.
It's covering the window, and you can run animations in LightStanza to make sure it really is working well. This is at the equinox. If we did this, at the solstice in the winter, we'll get it something different. And so you can use a tool like this to really understand this, both numerically and analytically, but also just visually, and you can really see what it's doing. Likewise, you could use LightStanza to look at different fenestration. So typically buildings have blinds or something else, and if they don't have blinds and people are irritated, then we'll put them up anyways. They'll block the glass with something. And so in this case, LightStanza, we can model on the right-hand side is the blinds being modeled. So this is how this particular space is going to be working at hour-by-hour intervals. You can actually see the blinds are opening and closing. LightStanza does all this work for you. Just drop in your 3D model, and then it will try to guess where your windows are, and then it will put blinds on them. You have the option of not seeing them because people don't like to see blinds, but the reality is if you're doing measurements, you'd want to just check and see are the blinds going to be closed at these times. And this is, I know there's some energy modelers here, so there's some analog with energy modeling that hour by hour we look at the weather, we try to see if the blinds will be drawn or not, and from that you can come up with a more accurate prediction of how your space is doing. And this is something that, for example, like USGBC requires for the LEED calculation. So one of the reasons that you may not be interested in doing calculation, that this is extremely painful to do this every hour during the year, right? I mean, that's not a fun calculation. Likewise, on this thing, on this side, on the left-hand side, you see electrochromic glass, and this is some generic dynamic glass. It's not a particular manufacturer, and it shows how your building will have its glass tinted. And so if you're doing a cost-benefit analysis of electrochromic glass or thermochromic glass, you could use this to sort of get a general idea of how it's performing. And we are working with manufacturer Sage Glass, who we will have a more specific algorithm, and we hope to work with many other manufacturers with this. So with this, the architect was able to evaluate whether or not the trellis was worth it. So trellis, older technology, newer technology for the classroom, we put on some dynamic glass so they wouldn't have to deal with this overhang. And you can use a tool, you could use LightStanza to figure out the cost benefits. And so as we all know with design, there's often how you can use different arguments typically on what's better. In this case, on the left-hand side, you can make a rendering here. I picked this time at 11:45 a.m. on the equinox, and you could look at the glare has been reduced with the trellis, and at the same time, the glare is actually being reduced even more by the dynamic glass. So, go ahead. Great question. So the question was the panes on the right. Each pane here is actually individually being controlled. It just so happens I picked a time that was really bad. Actually, in this case, I kind of tricked the data here. I basically picked a time where I thought the dynamic glass would be performing like a gloomy piece of glass because the sun's right on it. And then I picked a time where the trellis also blocked it completely. And so in this case, it's trying to show that the trellis kind of wins because you have clear glass to see out of. It's blocking the sun. And on the right, you just have tinted glass. And so you don't have that clear glass. If I continue to give information, this is just a partial, this is kind of a trick I did here, is that you can say, well, actually, over the year, dynamic glass does so much better, et cetera, et cetera. So you can use LightStanza to make these different arguments in your office. And so traditionally, these are extremely hard to compute. Has anyone tried to model dynamic glass, and how's your experience looking at? Okay, not great. So someone here in the classroom has modeled some dynamic glass, and it sounds like mixed experiences trying to model it. Yeah, so with LightStanza, you can make the renderings or do the numeric calcs, and it will do the hour-by-hour tinting by each pane of glass in your model. And so this is actually what the building looks like in Aspen today. So they picked the trellis, so. But I think dynamic glass is a great technology. This is the same building. So looking at the building in 3D, you can see vertical sections, or you can make vertical grids. And so in this case, the architect was concerned that teaching is going to be interrupted with glare. And so because students are going to use this atrium to sit on and teachers are going to talk, they wanted to measure whether or not there'd be just too much ingress of daylight, and that would be distracting and hard to work with. And so in this case, they ended up frosting the glass. So they picked that so it would diffuse the light. And with LightStanza, you can actually use different types of materials, clear glass or frosted, some type of frosted glass or translucent materials, and you could actually get different results. And so this was something to help them inform that they would have glare in those clear stories, and so they would frost the glass and not have those problems later. Likewise, this is a building, this is actually the San Francisco airport, and it was looked at, dynamic glass is looked at in LightStanza by Gensler. And so they were concerned that this is kind of a north-facing facade, but after studying it some more, they saw it was curved, and it kind of became northwest and northeast-facing. And by having those facades, you do get direct sun. And they weren't able to work off the facade with like a trellis or anything like that. They were constrained. So they were able to use LightStanza to really understand the value of some sort of more advanced system. So just as I said in the previously, that the trellis in that case sort of quote won out. In this case, this has provided them good evidence. And these are big projects, and as you guys know, there's a lot involved here, and you don't want to have a great design being value engineered out, because you can actually show some evidence of how this is reducing the heat off these big facades. Yeah, it's. Oh, okay, cool. Okay, great. Good person to have here. Okay, so this is the analogy, I guess, from the lighting way through it. So this is a bit of our lead report card, and basically there's a huge amount of detail that we automate. Basically, you put in your 3D model, you either draw your grids, or we have an auto grid feature where you don't have to do anything, and then it just spits out massive reports. And these reports, you can be compliant through option 1 or option 2. We actually run both options for you, just so you can actually have them both, and then you can pick, and both of them will tell you what your score is. And so if your score for option 1 is 3, that's going to beat out any option 2 score. If your option 2 score is looking good and your option 1 is 0, then maybe we want to encourage cutting edge simulation. That's option 1, but option 2 is somewhat of a legacy option. Sometimes buildings will be scored better on option 2. And so Dylan and I were at a workshop when we saw sort of a lead v4 workflow that wasn't using LightStanza, and it was a lot harder. So you had to go through these different steps on the left and on the right. In order to generate accurate results, they had to use text files. I mean, it was really a lot. It looked like a lot of work to get the accuracy that this consultant wanted, and it looked like they were just using option 2. So again, people that care a lot about accuracy, it's a lot of work. So I think that's why people don't do these lead daylight reports. That's one of the reasons, because to do them correctly, it's just a lot of coding, so to speak. Real quick with annuals, this is a project worked on by Point Energy Innovations in the Bay Area, San Francisco Bay Area, and he used LightStanza to look at some of the key lead metrics to understand whether or not they're getting too much solar exposure, and if they're getting solar exposure, you saw in the previous slide, they're looking at overhangs and how to reduce the solar exposure, and also is there enough daylight, so looking at the spatial daylight autonomy of the building. Okay, so lastly, we're a web-based tool, so we run quickly. We take the data and we process it on our servers, and you can run actually multiple things. You can close your laptop, you can close your workstation, they'll still be running. And we try to put multiple servers on your project, and we have different tiers of service and that are on our website. And also you can just continue to work and not get slowed down. So from there, I'm going to hand this off to my colleague, Sydney, who's presenting remotely.
Hello, can you guys hear me? Hello?
Yeah, we can hear you here.
Cool. All right. right, so let me show my screen. Sure, okay. All right, is everyone able to see my screen?
Yes, Sydney.
Okay, and do you see the app up?
Yes.
Okay, great. All right, so my name is Sydney Nelson. I am talking to you all from Boulder, Colorado. That's where the LightStanza office is. And I'm going to try to just show you how to get the results Dan just went through kind of from start to finish in a kind of quick demo of the app. So I'm going to use a model that I've already run a few simulations on. This is the Fort Collins Utilities Administration building, and it just recently achieved LEED v4 Plaque. So we were excited to work with them on such an exciting project. This was RNL Design in Denver, Colorado. So I'm going to open that up. So I'm on app.lightstanza.com, and the first thing I do is make a design and enter that design. Get that loaded. So the first thing you'd want to do is upload a model, and that's with this button right here. I've already uploaded a model, as you can see, but Dan mentioned we can upload SketchUp, Collada, or IFC files. So that would be SketchUp, Revit, Rhino, ArchiCAD. And you also have an option to upload from a sample model library if you don't have a model available. And basically, our app, or the design page, is different sections. Let's see. 3 different toolbars. So we have our left toolbar, our top toolbar, and our right toolbar. And I'm going to kind of display or demo this just separated into those 3 parts. So the top toolbar this is just going to be our design name. You can change it here. Once you've uploaded a model, you can download it back to your computer. And again, this is where you can upload a model to LightStanza. This little box right here is how you can navigate the 3D viewer. So there's the rotate, pan, zoom, and then just a look around. So look around is good for looking around a room. And then another useful one is the wireframe mode, and that's really useful when you're looking at data in your 3D viewer. So I'm having difficulties with the screen, but yeah, look at data in your 3D viewer, and I'll show you kind of how that works in a little bit. The next, and this top toolbar is going to change a little bit throughout the demo, depending on what data I put into the screen. And I'll do my best to kind of explain what additions there are to this top toolbar. But now I'm going to go to the left toolbar, and that is basically how you can edit your model. So it's basically your model settings. So the first tab here is the Viewpoints tab. And these were just uploaded from SketchUp, or they can be uploaded from Rhino. And they're basically, scenes or viewports. And you actually don't need to make these in your CAD tool, but we do upload them. So basically what these will do is just bring you to the spot in your model that you made a scene, for example. They're good for making renderings, and that's over here, but I'll show you how to do that in just a little bit. This is our illuminance grids tab, and just like the viewpoints tab, you don't need to make any illuminance grids in your CAD tool, in your 3D modeling tool. LightStanza is able to make these for you upon upload. We'll do an intelligent guess where we think that your illuminance grids should be. And as you can see, as I scroll over these, some of them will highlight. That's just basically connecting the list with what's in your model. Another thing you can do in your illuminance grids tab is just turn them on and off. So if you're, for example, making a LEED v4 scorecard and you want to turn off your unoccupied spaces, just click the check here and it won't be part of your simulation. And we also have a flip grid that'll just flip it upside down. You want to keep the yellow side of your grid where you want to measure light. And I guess I should mention, if it wasn't clear, the illuminance grids are basically just where you're going to measure light. So, for example, just a regular illuminance grid annual metric, but I'll go over that in just a moment. The next tab here is our Materials tab, and basically we have two sections. It's in Design, and that's going to be what's in your model currently, and you can see as I hover over these materials, it shows you where they are in the 3D viewer. But if you want to go into LightStanza and, for example, apply more daylight materials, you can click on Material Library. And we have a library of materials here. Just regular glass, opaque, we have some translucent materials, then we have some more complex glazing like daylight redirection film, frit, etc. So let's say I want to add dynamic glass to my model and see how that works. Maybe I want to try dynamic glass instead of overhang. So I just clicked it and it brought me into the design. And what I can do is use this paint bucket tool to apply it to a window. But you can see it would be pretty tedious with this model to apply it to every individual little window pane. So what I would do in this situation is go up to where what it is currently, which is double pane glass, click Select All, and then apply dynamic glass that way. Another thing you can do in the Materials panel is edit the materials. So I don't know, I wasn't in the room, but I think a few of you work with Radiance properties, so you can either edit the materials just in a simple form, or you can click View, Radiance Format, and then you can get a little bit more details, and you just edit them directly, click OK, and that's going to change the properties of your materials if you want to get really custom. You also have a Blinds tab. And Dan mentioned that LightStanza automatically adds blinds to your model upon upload. So in this tab you can basically just change the blinds material, or you can also change the properties of your blinds. So we have it set to dynamic, so that will open and close based on that 2% direct sunlight rule that's used set by the USGBC for the spatial daylight autonomy calculation, but you can use it for any type of calculation. But if you don't want to use your blinds, this is where you would say, okay, always open, I'm turning them off, or always closed if you wanted to look at your performance with them always closed. And then a few other things on this tab. Two more little tabs in the left toolbar. We have our layers. If you have a model with a lot of layers, you can just turn them on and off in this tab. If you turn them off, they won't be included in your simulation. This is good for things like turning overhangs on and off or things like that. And then there's our Site tab, and that'll just be where your model is located and its north angle, and as well as the climate station that's associated with that model location. So if you do a calculation that uses weather data, you're going to want to make sure that your model's in the right spot, so it's pulling from the right climate station. Let me check how much time okay. Alright, so the fun part, though, is the right toolbar, and that is the activity bar. Let me try to move this out of the way. Here we go. So the activity bar is basically where you can make new activities, and here's a list of the different activity types that you can make. You can also check the status of current activities, so you can see I have a really big simulation running right now. You can cancel, so I'll just show you, you can cancel it. A simulation here, and you can go through and look at previously run simulations and click on them. You can then view them in the 3D viewer, or you can view them in report style. So let me show. So let this fill the 3D viewer. It's taking just a moment. Big model. But what I'll do now is just take you through each of the different simulation types that you're able to run. So I'll start with rendering and animation. And again, so the renderings, if you want to make a new rendering, it's going to take the exact position and angle that your screen is at right here. So it would basically just take a photograph of your viewer. So if I wanted to, let's actually turn this on. If I wanted to make a rendering here, I would have a few more options before I click Start Simulation. You can choose the quality. We can do draft high, very high, and these are based on some radiance quality details. if you really want to make it custom, you click Show Quality Details, and you can edit all of these individually. I'm just going to keep it on a default for now. And then we can adjust the quality of our rendering, so super sampling and resolution, you can adjust those. So, for example, the resolution, you can change the pixels all the way up to in the thousands. And then we have something that's very important to pay attention to is the period. So if you click single point in time, that's going to just generate one rendering at a specific time, and that time is going to be what you set right here below it. But if you want to make an animation, you can click 1 day or key time. So for example, if I want to do 1 day for a range of, I guess, let's say 9 a.m. or 9 a.m. to 6 p.m. for 15-minute intervals, I could do that. So I'll show you kind of what that would look like in just a moment. The other options are the sky type, so clear, overcast, and then like I mentioned with the site tab, if you want to use climate, just make sure that your model is pulling from the weather station that you prefer. Then a few more options, use blinds and lens. So lens, you can choose between perspective and hemispheric. Perspective is just going to be kind of how we view it, and then hemispheric is like a fisheye. And what you'll get with a hemispheric is a more accurate representation of glare with the daylight glare probability score. So I've already run all of these simulations for the sake of time, but if I was to click Start Simulation right after that, I would have gotten something kind of like, you know, this would be an example. We'll let it load. And as I mentioned before, this top toolbar is going to change as I change what's in the 3D viewer. So I'm loading in animation, and so that's going to add an animation toolbar. So a play right here, back, next, and then the time that your point in time represents. We also have a set of camera tools. Dan showed you something kind of like this in his presentation. But here's that false color that he was talking about. If you want to focus in on really specific levels of light, you can change the luminance bounds or log scales here. And then just a different way to look at it is with contour lines. Let's see. So another type of simulation you can do is an illuminance grid. We have point in time and we have annual illuminance grid. So I just clicked grid illuminance, and very similar options to the renderings, but for the illuminance grids, you're going to want to pay attention to your point spacing. So we'll try to guess what a good point spacing is for, you know, a fairly quick simulation, but you can choose whatever point spacing you'd like. And then again, click Start Simulation. You can do animations or individual point in time with these as well. And I'll let that load. So here's where that wireframe mode is useful. And here it is. I'll click play so we can watch it animate. Get to a good position here. And like I said, top toolbar is going to change a little bit. So here you can see the legend for your illuminance grids will change depending on what you have in your 3D viewer. And then you'll get some more numbers here. So for the point-in-time illuminance grids, you'll get your average lux values. Another simulation type is the annual grid illuminance. So that's just basically, that's very similar to the point-in-time grids, but you have 6 annual metrics to choose from. I don't think I have much time to go over each one of these, but we do have some documentation online at lightstanza.com, daylight terms and metrics, as well as our help guides, where you can read about every single one of these and kind of how we show them. But for each annual metric, you can choose between 3 and 5 phase. We definitely suggest 5 phase. It's the newest method for calculating annual metrics and the most accurate method. You can change your occupancy for each day. So, for example, maybe a hospital might have different occupancy hours than a school. And then a few other bounds that you can change depending on what annual analysis you choose. So you can really customize these to get the information you need. So I have run all of these before, so I can at least put them in the 3D viewer for you right here. And I should say that you can also view these outside of the 3D viewer in a report format and view individual spaces like this, download, print, whatever you need to do. We have two other different types of simulations you can do. We have the lead scorecard. So with your lead scorecard, you can do lead v4, option 1, option 2. You can run options separately, or the lead 2009 if you're still working with that. Quality and then point spacing again. You're going to need to go under 2-foot point spacing for a lead credit. And then we have our daylight factor for those overcast climates. So I will show you quickly a lead v4 report in LightStanza. So we'll click right here. So this is a pretty complicated report, and so that's where these tooltips are pretty handy. You can find these little eyes all over the app, and we do our best to kind of give you as much information as we think you might need. But don't forget to hover over these whenever you're using the app. But this lead v4 scorecard, as Dan mentioned, is going to have option 1, which is spatial daylight autonomy and annual sunlight exposure for possible points, and then option 2, which is going to be 9 a.m. and 3 p.m. on a clear sky day near the equinox. And each one of your reports is going to have a big list of details that you might want to check. Again, print, download for anything any results that you generate in LightStanza, you will be able to find a download option. Let's see, one more thing. We do provide SVGs for any of your illuminance grids. So just go into your report, click on one, and you can zoom in and get the actual data points. So I know I went through everything very quickly, so I'm going to hand it over for questions right now. But before I go, on LightStanza, there's always help right here, and hopefully that can at least help get you started with LightStanza. So I'm going to hand it back over to everyone for questions.
Hey, thanks, Sydney. Does anyone here have a question about what's been presented? Okay, online?
Yeah, I've got an online question here. The blinds in LightStanza, are they based on a specific algorithm, and is it possible to simulate both manual and automated blinds in the algorithm? And if so, which algorithm is it pointing to? Is it using? Yes, it is from Amir.
Okay, thanks, Amir. So with the lead v4 calculation, it's prescribed by lead v4, which is basically they're trying to model what people would do in buildings by kind of making people like machines, and so it's kind of a we follow the lead v4 spec, which looks at how much daylight gets into the space, and if over 2% of your space is hit with direct sun, that's when the blind gets triggered. So we're actually measuring light inside your space, and so that was the model for people. But as people may have noticed, that looks kind of automated because people aren't necessarily that precise. So we do measure the blinds opening and closing from inside the space. The other way that we measure, when you make these renderings that can show the blinds changing position, is based on the illuminance on the glass. So if it reaches a certain threshold, lines are drawn based on the illuminance on the glass. So those are the ways that we look at blind automation. So yeah, thanks for the good technical question. And hopefully people understood what I was saying, that we're modeling people kind of like an automated machine. But that's kind of an insider thing, that when people talk about, well, how do you model how people use things, and you give a formula, like, well, is that formula better than the machine, or is it? So these are just ongoing conversations in the daylighting community. Other questions?
Quick question. I think feedback that I commented like, well, or something that you can
Sure. So there's a question about, short answer is yes. We want to work with energy tools. And the question specifically is, since we model daylight really accurately, can that information be handed off to your energy tool to understand schedules of when things are going to be dimmed? And so the short answer is yes. The longer answer is we're not there yet, but we have plans. We have daylight autonomy plots. Those are the features that Sydney didn't run, but those plots basically show you what percentage of the time of the year do you meet certain thresholds, and you can sort of indirectly look at those things and convert them. So that's a good question with the energy, from the energy side. Yeah, other questions?
What was the parametric analysis that we have a classroom when the depth is the size, things like that?
Good question. So the question is a parametric analysis looking at different configurations. So right now you would probably need a tool to use before this to maybe do those things. Right now the way that you do it in LightStanza would simply be with something with like layers. So would you want to do that programmatically? Is that your main interest, or would it be in actually? So if you wanted to try two different sizes, you could put two different walls in your space, and one wall you could turn the layer off on or turn it on, and that's how you would do it. Yeah, so that's how we currently do it, and we can talk after about what if you have any other ways that you're thinking about it. Okay. Yeah, I think daylight's hard. I think often when I see people programming things and saying, well, I've made the optimal daylit building, going back to that school where you have a electrochromic solution versus just an old school overhang with a trellis, some of these decisions get to be non-computable. I mean, how many people feel you can make arguments? How many people think the trellis wins? That's a definite winner, the trellis in this. If people can remember that school, how many people think that the dynamic glass is a definite winner? Okay. How many people think it depends on other things? Yeah, so the concern I have about just automated systems that just tells you the optimal daylight and builds it for you is that it may not, it may be racing faster than or slower than your designers are kind of working through the problem. So yeah, but we do have people using layers right now to try out different configurations quickly. Yeah. Other questions or?
What's the typical turnaround time we get back?
Great. So the question is, what's the typical turnaround time? So it'll depend on multiple things. So good question. I'm going to give you an answer that has different. It depends. So turnaround time is going to be great compared with a desktop computer. That's the short answer. The longer answer is it depends on what you're doing. If you just want to make a rendering, that'll come quicker. If you want to do a full building analysis that does annual calculations, that looks at blinds in every positions hour by hour, depending on your facade, that may take a couple hours. And we offer different classes of service, and so if you sign up and you have sort of a free tier, then we offer a pro tier that gives you twice the computing power, and then an enterprise tier, which gives you 4 times that computing power. So it's a bit nuanced. So to be honest, certain jobs that are just hard, they may take a couple hours, but a lot of jobs will finish within 5 minutes, and some of them will be in seconds, depending on the complexity of your model. If it's just a shoebox model, you can get some information very quickly out of it. So, but yeah, that's a good question. Yeah.
You mentioned thermochromic glass.
Yeah, right.
With electrochromic, but I hadn't heard yet about thermochromic. I think I know what that means, but could you talk about that?
Yeah, so thermochromic glass, the glass tints just based on the heat on the glass. And so it's a simpler quote technology, which has advantages and disadvantages. And so it has advantages that you don't need electrical wiring to it. It's just a film you put on. And the disadvantage of it is it's heat sensitive. So in Colorado, for example, in the morning when we go to the office, we have an east-facing facade, and it's the winter, and there's snow on the ground, and it's really cold outside. We'd want to have that facade tinted immediately when we come in, because it'll be really glary in the morning. We'll have sun in our eyes, and so it may not be as quick as responding as an electronic system that can sense the sun and just immediately change it. And so I think it's more affordable because there's less stuff to make it work. And there is a manufacturer, Raven Window, actually in Denver, and I know there are other manufacturers that produce that technology. So yeah, it has some strengths and weaknesses compared with electronically controlled glass. So good question. Yeah, and so what we want to do is, with a generic, is just simply provide a generic so you can make some, pretty informed choices versus the alternative of not having a tool like this. It's just really hard, I think, to model. And we typically see people we want to make this process simpler and easier, and we hope people here will embrace more daylight modeling. How many people, how many people here do daylight modeling right now, or how many people think their life could be easier with this, or so the hope, and if people want to take up our trial, you can also talk with our sales, and we'd be happy to give you a 25% off, like an annual subscription, if during this month you guys think it's a good thing for people that are here or even online. We really want to encourage daylight modeling. It's always surprising for me to see that there's so few people, going after daylight directly. We feel that people, it's really desirable, but it's kind of perplexing to me that there hasn't been as much. When I look at the USGBC, when people go for their points, daylights is rarely gone for. We hope that this will reduce a lot of the barriers for doing the modeling, and that you'll see the benefits that we talked about in the beginning. Any other questions online, or? I'm sure he does. We can continue to talk. So yeah.
All right. Well, thank you very much. I appreciate the presentation.
Thanks, everyone.
Also wanted to just mention the lunch in this presentation is thanks to Idaho Power. So thank you, Idaho Power, for the barbecue and the chance to learn more about new daylighting, making it easier, which is great. And there are evaluations in front of you if you wouldn't mind filling one of those out. And if you have topic suggestions for next year, we've got our first speaker lined up, but we're still looking for more. So if there's a particular area of interest, let us know. And